Try to got a hold of one of us here, and we're here to help with anything. And I guess I needed to introduce Mr. Tony. Some of you guys might have already been in the previous presentation he just did. He's helped us out with a lot of these presentations. He's been in the industry for a long time. Most of you guys know his backstory at this point. Wanted to mention real quick, if you guys did miss his previous presentation here on light duty electrical, that will be available on demand for about, I believe, 30 days. Really good presentation there to watch. I know it helped me a lot. And I guess, yeah, without further ado, here's Mr. Tony Salas.
Well, thank you, Mr. Omar, for having me introduce. We all appreciate what these guys do at Alliant Power. They answer a lot of technical calls, and I've seen them when I go to the Denver facility, how they're working that line. So in this case, those of you that are calling and helping them out, I mean, not helping out, but asking questions, obviously they do quite a job. And then the number of calls these poor guys take, is amazing. So I also give my number out for technical help too as well. And my God, the calls that I get versus they get, I can only imagine the load. So Omar, thanks to you and the crew and Beth and Beto and also Mike, all the stuff that you guys do along with Scotty. You guys do a great job, So with that said, welcome back. So those of you that come back for more information, we just did, yes, like Omar had stated, I just did the light duty electrical. Took a quick sandwich here, and now we're back here with changing the subject with RAM Cummins 6.7. Therefore, this is more product specific. Here to talk about some reviews of the 6.7 along with the after treatment. Now, let me first get started and tell you one things that I talk about in my Diesel Master course and my courses is about Cummins. And what I'm about to tell you, I do not take lightly, nor is it meant to degrade or tell you, but the fact of the matter when we diagnose trucks, because let's face it, when we diagnose trucks, what do you do when all else fails? You follow published documentation, you follow charts, you do what you're supposed to do, and things don't make sense. And in this case, one thing we've learned about Cummins, and again, this is something that I talk about, and don't challenge me. I'm just telling you it fixes. My goal is to help you. So with that said, is that I have this thing which we talk about Rams Cummins computers, is that I call it a latching effect. Yes, a Tony made up term. I call it the latching because there have been some instances where a RAM Cummins 6.7 actually will be locked into condition. For example, the truck will come in with a high idle condition, and you look at the common rail system, you look at everything, and the problem is the system is actually locked in to dealing with that high idle, and you might repair the issue. Maybe you did find an issue. And what we have found many times is that the Cummins computer on these RAM 6.7s tend to lock into a condition. And there could be other array of diagnostic scenarios I could discuss, but obviously my time is limited. I guess what I'm trying to say is when a computer, like I said even on the first presentation, is that when the computer acts silly or stupid, it's because something's making it do it. So if you come across a RAM Cummins truck and it doesn't make sense and you checked everything you could and it does either high idle or it has a dead hole and you know that it does operate, I mean, various different things. Sometimes it's simple as resetting the whole system. And how do we reset? You take off both battery terminals on each battery, and then with all of them disconnected from the battery, you actually connect the positive and negative of those cables together. And what you're literally doing is you're dissipating the capacitors in the computer. And sometimes that actually lets go of that latching effect that these computers have. So as I've done my courses and I visit shops like I am right now, we have repaired numerous different RAM Cummins 6.7 with that. So there's a quick tip that may help you. And again, you're going to remember me when I talk about it when you get these RAM trucks that actually have issues. And this could also affect after treatment behavior, which we will talk about here in this presentation. So we're going to review and talk about the changes and updates. Again, some things about if you haven't seen what's going on, they did use the CP4 for a few years, just a couple of years, that's it. and obviously went back to a CP3, but we're kind of wondering about that CP3 they're putting on now on that truck. And diagnostic approaches with the after treatment systems along with SER updates. So first of all, when you look at a Ram Cummins, please remember it is a Cummins engine. So there is going to be a serial number. So many of us actually still visit a Cummins dealer to actually buy certain engine parts for it. So you can buy gasket seals, various things related to the engine. So please note there is a serial number, and that serial number is usually on the valve cover, as you can see there. And you can also see various other reference numbers too as well. But again, the serial number is what you read. Yes, we can read it on the scan tool and we could read the serial number, but in the world of Cummins, not Ram or Dodge, as you guys know it as the older trucks, or FCA, it is known not by VIN number, but by serial number for those of you that are car guys, you know. So one thing, excuse me, one thing we've been talking about is actually there's apps out there, Cummins that have the quick service online app. You can actually enter the serial number off of the those Cummins trucks that are found, and you can see one that I did on a Ram truck there. So it does give you data. So you have some, because obviously it is a Ram truck body. It does have Ram truck attributes, but it is a Cummins engine. You can still read and get some part numbers for various different components on that 6.7 engine. So bear that in mind. So I thought I'd throw that in there real quickly in terms of using the Cummins app as well, along with using the service information too. So, all right. So therefore, that's what we're looking at. Backtracking. So again, anyways, going to the next slide. And in this case, when we talk about scanning the vehicle, it's not coming, I don't know if it's coming up there, but in this case, when we talk about scanning the vehicle, please note that you're going to notice much of today's software, like I use my scan tool. And what we do is we actually have the need to do a complete scan. And as I visit shops in my current travels that I'm doing right now, it's nice to see that technicians are doing full scans. In other words, let's see the big picture. In other words, you're looking at ECM, you're looking at transmission control module, and you're looking at all the sub-modules such as ABS and so on, because when you do a complete scan, you do want to look at the big picture of what's going on there. So please note, I would hope that you have a diagnostic process when you diagnose, and I hope that scanning is not the first step that you do, because in this case, there are some visual inspections that we got to do in our diagnosis. So I don't want you to think that I'm scanning right away. No, when I do diagnosis, no. When we come to the step of diagnosing and going and looking at the codes, it is in the hopes that you actually do a complete scan. So that's what you want to look at. But anyways, definitely want to pay attention to what we have going on there. So in this case, when I do a complete scan, definitely want to see what's going on there. So apparently it's not moving forward, but we'll just skip that for now. Now, the other thing you're going to see is the after treatment system. As you look at an after treatment system, that has been a major thing. So let me stop. If you don't know after treatment yet, shame on you, especially if you're a diagnostic technician. Do you know the function of a diesel oxidation catalyst, diesel particulate filter? Do you know the function of an SCR? Then therefore, we got to go back to 101 basics of SCR. For example, when I talk about DEF fluid injection or AdBlue, we know that that DEF fluid or that AdBlue readily converts to ammonia. You know, I'm sure Carl talked about that earlier. I didn't get to see you, Carl, but in this case, I'm sure he did speak about the DEF fluid, and in this case about after treatment, where we actually create ammonia. It is the ammonia that breaks the NOx. But what I'm trying to stick to right now is understanding how things work. And it kind of goes back to that saying I've been teaching for years, that isn't it fun to work on something when you know how it works, right? And in this case, we have to know after treatment and all the subsystems that are in the vehicle. Because let me tell you something. If you're diagnosing on a Ram Cummins application a after treatment issue, the problem is that we need to make sure that the engine is running at optimum levels, and that's very important. So in this case, yeah, we do want to pay attention to that. So always remember, diagnose is to figure out the problem, isolate the issue, understand the failure, and determine what caused the issue to prevent repeated failure. While repair is the actual manual labor, you know, when you're taking on and off parts. So what are you? Are you both ideally, or are you just a guy that just replaces parts and you're checking to see what's going on there? So you're guessing at it. And we see that still to the day when I visit shops that need training, is that, well, they already put this part on, they already put this part on, they already put this part on, and still not getting anywhere. So please note that, again, isn't it fun to work on something when you work? So that means you would need to know after treatment as well. Very important for you to do. So again, figure out the problem. But did you notice the last part? Understand the failure and determine what caused the issue to prevent that. So therefore, we want to also prevent it. Because success means that you don't want it to happen again. We don't want this truck to come back. So as you look at, since we were talking about briefly about after treatment, I showed you the previous one. Here's an early model, 07. And the 07 had just nothing but the diesel oxidation catalyst and the diesel particulate filter. That's all we had. So therefore, as we look at that and we talk about that, there was a problem. And the problem was these systems would run cold. So when we talk about after treatment, we're talking about, how well is that system operating, how efficient it is. And a lot of it has to do with heat. Heat is what we need with the after treatment as we work with this. So yeah, it was a problem with some of the early catalyst systems or after treatment systems. So you can see early model with the close coupled catalyst, the NOx absorber catalyst, and we had our diesel particulate filter way downstream is what we saw, excuse me. So with that said, got a little sniffle there. But in this case, as we look at the later model after treatment on these Cummins applications, in other words, on the Ram Cummins, you're going to notice something. Our traditional after treatment systems have been using diesel oxidation catalyst, you can see there, and you can follow it and you'll see the diesel particulate filter, but then you're going to see the SER assembly. Okay, that still looks familiar, but look at the last component. In this case, there's the ammonia slip catalyst. So unlike Cummins, unlike Duramax, for example, Cummins on these Ram trucks uses an ammonia slip catalyst. But then again, we have to note what ammonia slip is. So one of the things I read about in classes, and we looked at the service manual, that, the excess of ammonia left over, what happens to it? Well, in this case, we actually have the ammonia slip catalyst, but then we call it ammonia slip. So what is the definition of ammonia slip? Ammonia slip is the excess ammonia that's left over after the after treatment. In other words, after we did the NOx reduction. The funny thing is we were reading this text and on this service information, and it actually stated that when there is excess ammonia left over, the NOx sensor 2 cannot tell the difference between the excess ammonia slip or the leftover DEF fluid or ammonia. Again, let's just call it ammonia slip. And in this case, the excess ammonia slip, it can't tell the difference between ammonia slip and the actual NOx content. So therefore, please make a note that on those trucks that don't have ammonia slip or an ammonia sensor, because that's what this truck has, that's why you see an NH3, that is the ammonia. NH3 is ammonia. And in this case, that ammonia sensor cannot differentiate between excess ammonia slip and NOx. So therefore, he thinks there's more NOx that's after the after treatment. So in turn, the strategy is going to be to inject more DEF fluid, which in turn will create more ammonia, and there'll be excess. So I guess the latest thing we have seen with trucks nowadays is that they're consuming. You might get a complaint for excess consumption of DEF fluid. And that may have to do with the fact that maybe the catalyst is just not getting warm enough. If we're not getting warm enough, in this case, we're not going to take advantage fully of that DEF fluid, which turns into ammonia. So again, it isn't surprising that somebody will run a regeneration, and hopefully you got the code 1451 set, because let me tell you something, you cannot do, as of, let's see, 2019, where I've worked on, you need a 1451 code on these trucks for it to allow you to run a regeneration. So in this case, that means I can't do a regeneration at will like I do on a Ford or a GM product. So with that said, I'm trying to tell you that you have to actually have a 1451 to run a regeneration. So definitely, if the truck comes in with that 1451 code, you don't want to clear it, because that is giving you the green light to go ahead and run a regeneration. So definitely want to pay attention to that. If not, you're going to be in trouble, because how are you going to run a regeneration? You can't. So that would mean the option B, if it's not in D rate, at that point, you're going to have to go drive hard the truck. And I mean hard the truck, and actually get it nice and hot. So I'm sure Carl covered it, but again, please note that we need to get nice and hot in order to have a perfectly efficient after treatment system to work properly. But again, what we're trying to show you here is on these Ram Cummins application, there is a ammonia slip catalyst, and that's what you're going to see there. So the diesel and emissions, it all comes down to, again, what's going on with the engine. So let's be fair here. I'm straight up about things, and since I don't work dedicated to manufacture, I can say this, and that is, when we look at these trucks such as the Cummins 6.7, these engines are pretty much very constipated and congested, and if we don't watch the maintenance, we're going to have problems. So yes, I do disagree with the maintenance that we're calling for. In this case, on one hand, you're creating a pretty much, you got the EGR and you got pretty much all that volumetric efficiency being affected for NOx control. So therefore, in a way, we're actually congesting. You got even an EGR throttle plate on the intake, right? And then on the exhaust side, you got your diesel particulate filter and everything else in there. So therefore, in a way, we're sort of like congesting and constipating the engine. So again, who pays the price here? And in this case, a lot of it is the actual engine oil. So I understand that some manufacturers, such as Cummins, I've been saying in the past that we call for about 10,000 mile change intervals. So no, I don't agree with that. And for some odd reason, our industry has accepted that, the less we change oil, the better it is. No, we got to be maintaining these engines. So in this case, but there's other factors that affect. How is the vehicle driven? Does it run a PTO? Is it a fully equipped fleet truck? What is it? Does it do a lot of stop and go driving? Or again, our highway speed's limited, not to mention, is it in a temperature that's too hot or very cold? It all depends. Those are many factors that affect this, but it all comes down to this, is that do we need to step up the maintenance on these trucks? Because when I talk about the common rail system, we often say, what is the number one enemy of common rail? And in this case, it is contamination. So fuel filters are another problem as well. So in this case, definitely want to look at the fuel filters and see what's going on there. But you better yet, let's just change it more periodically. So what am I recommending? Yeah, we're going to change those fuel filters every other oil change. And you probably think I'm crazy. But again, we cannot actually protect and safe enough that common rail, because you talk to anybody that's done injectors or rebuilds pumps and injectors, they will tell you the very common thing they found in systems is contamination. And if you're taking apart a common rail system on these Cummins, you ever stuck a boroscope inside the rails and see what kind of junk you might find inside of the rail? And it might be scary. So keep that in mind. Again, maintenance is the greatest thing we got to understand about this. But as we talk about the Ram Cummins 6.7, the 6.7 through the years was introduced in 07 and a quarter, or 07 and a half, excuse me. And in this case, the first earliest was 6.7, because we went from the 5.9 with minimal emission controls. And all of a sudden we went to the 6.7, and poor 6.7 started off badly because it had every imaginable emission control on it, from EGR all the way to DPF on it. So therefore that's where it went. So then they went with other things to help it, because we saw issues with the variable vane turbos as well. But in 2010, for example, it eliminated the TCM. So there were also some hardware changes as well, along with other design differences, such as your thermostat housing, as you can see on the screen. So I guess what I'm trying to say is there were different, different changes there that we saw, especially in 2011. What did we see in 2011, these trucks? We saw the introduction of the SCR. So obviously we're using SCR, like we showed you the system earlier, to actually go after NOx. And if you've never taken a class on aftertreatment or understand what's going on in diesel, those of you that are new and visiting, let me tell you something. The only two key emissions that the government is after for emission control on a diesel is soot and NOx emissions. That's the only two we're going after there. So yeah. So as we move along here, we look at the original numbers of a 6.7 liter. Again, 12 quart capacity, 15 W40. Again, you can see the average weight of these motors. So, but again, the 6.7 did start off, unlike the 5.9, with kind of a bad start, like I said, because of all the emission controls, and that's what people don't like. But you can see through the years, obviously I'm not going to read through there, but there have been significant changes from calibration to horsepower, to torque, to transmissions, to also engine updates. For example, in 2019, you could see there that the horsepower was bumped up along with the torque, but there were improvements to the block, the camshaft, cylinder heads, along with updated valve springs and rocker arms. So since I mentioned rocker arms, you do understand that these Cummins 5.9 and 6.7 need I wouldn't say periodic, but not as frequent, but we need to do valve lash adjustment on a lot of these. And if you owned or know about a 5.9 Cummins, you do understand that we've been also talking about doing some maintenance, if not valve lash adjustments. And those of you that already have worked on it or are working on 5.9s and 6.7, I hope you make it a habit that if you're doing injectors or replacing injectors, first of all, when we replace the injectors, if you isolate, that's the issue. You do one or whatever injectors you're doing. It is a wide idea while you're in there. Let's go ahead and add to the job the valve lash adjustment. Let's adjust those valves. So let's make sure they're nice and tight. They're not out of spec. And in this case, we want to make it a habit, I guess what I'm trying to say. And you could charge for it to the customer. You're doing the customer a favor, especially if they've never done it and the truck has over 100,000 miles. You should be adjusting the valve lash on there. So focus to keep in mind. Not to mention, as I pull the injector off, make sure you cover your butt. Go ahead and measure compression while you're at it. So you should have the compression adapter so you can do actually a compression test, make sure it all checks out. And if you really want to take it a step further, you can take the rocker arms off and you can go ahead and do a leak down test on it. So therefore, that'll tell you more what's going on with the block. Now, I know there's a lot of you that like to do the relative compression test with a scope, and that's fine. I'm not docking you, but in this case, since I'm already in there, I can actually do some of those checks real quickly to see what's going on. So keep that in mind. But anyways, as we look at the different horsepower and torques, you're going to be able to see that we see the different horsepower and torques. And obviously, there's been a horsepower war and torque war. And, last we were at 370 horsepower, 850 pounds of torque, but they're actually reaching over 1,000 foot-pounds of torque now. So in this case, right now Ford is the leader at 500, but I'm sure they're going to come close around the 400 pluses that you're going to see for horsepower. So, yeah. But please note, along with that, it comes with a price to pay, and that is, again, the horsepower and also the maintenance and the work this engine is doing. So, yeah. Now, one thing that really discourages me, and I know that some people will disagree, but as you know, like we could see in this picture, I thought I want to mention is that, us, for example, where I'm home based out of Las Vegas, we actually have our biggest emission or contaminant is dust. We're in the desert, so there's a lot of dust. And I really dislike the fact that they went with capless. And I know that in the aftermarket, they sell a magnetic cover you can put over that to cover that. Because again, the minute you put that nozzle in, any dust or trash is going to accumulate. So it isn't surprising to find these tanks actually substantially dirty because, again, contaminants can come in. But again, that was their desire. They had their own mindset on how that this should be set up. But just understand that filtration is very key critical to this. And since we're talking about the filtration, here's your common rail on these 6.7s. And what's interesting about Cummins 6.7s along with the 5.9s, even to the day, is that they never went, excuse me, as of 2020, they never went to piezo common rail. It's all solenoid style. So we started off with the early ball and seat injector, and that's what we saw there. But in this case, that was useful for the fact that we can do leak down tests, and some of you guys do return tests. I have my own way of testing where I actually do a leak down test on the injectors because to me it's a lot easier. Heck, I often visited old timers. I like to work with older mechanics that have been around for ages, and I like to hear their perspective because I'm like, hey, you know what? You haven't had any training classes. So I know you're fixing these trucks. How are you finding out if you have a high return? And I know you're not measuring the return. He goes, well, you know what I do, Tony? He goes, I disconnect the line that goes between the pump and the rail. And what I do is I have my own banjo adapter, he goes, and I actually connect it to a clear hose. And what I do is I put shop air. Yes, he put shop air in there. He put shop air on that rail, and what I do is I put this hose coming off the back of the head, and I actually put it to a glass of water. If it blows bubbles, then I know that one of the ball and seats inside those injectors are leaking. You know what? It works for them. So that's telling them. And then he says, I welded shut these little lines, and I actually start capping off with my makeshift lines, and I see which one is where the bubbles stop coming out, and that's telling me that's the injector. So in this case, it isn't surprising what a lot of people have figured out on how to do a return test. So it isn't surprising that some guys do return tests and some guys don't do return tests, but I got to tell you something. In my Diesel Master course that I teach over in Las Vegas, I have this exercise where we have a 5.9 engine on the stand, and I tell them, all right, I want you to install the injectors and install the tubes, and then we're going to leak test it to see if there's any leaks. We do have the adapters to do that. And let me tell you, I can't tell you how many guys don't set an injector correctly along with the tube. So I'm glad we covered it in the class, but those of you that tend to know who I'm talking about. And in this case, what I'm saying is, do you know how to make sure you don't have a leak between the tube and the injector? Now, As a trivia question, I like to ask these trivia questions. Why do we replace the tubes? Why is it that they recommend the replacement of the tubes every time you do the injector? Well, one main reason is inside that tube, there is a filter in there. So therefore, we want to make sure we replace the tube, because if there's any trash in that filter or that inside that tube, we're actually going to have an issue there too. So definitely do the tubes along with the injectors, so hopefully you know that as well. So, but when I talk about Common Rail, I did a webinar last week, and in this case, I was talking about this webinar, and I was really in a fussy mood that day because I was very frustrated with the texts and phone calls I was getting on my phone here. And in this case, because I give my phone number out, and they were Common Rail basic questions, and in this case, it was really frustrating me. So again, you got to know Common Rail is a low pressure side. You cannot diagnose the high pressure side if you haven't verified there is lift pump pressure and volume. So I agree with Cummins, where they want you to do a volume test. And the magic number that I work with is we got to have at least 1 liter in 30 seconds. That's the minimums that I like to see. So therefore, we do volume tests. You can measure pressures all you want, but you want to know if you're getting the volume from the fuel tank to the injection pump. So in this case, what I'm trying to say is you need to make sure you check that. Don't even look at the high pressure side if you haven't verified that there is lift pump volume. Better yet, you can look at pressure, but I like to see volume. And yes, I know about the 10 PSI number some of you are using. But in this case, we definitely want to look at volume. And I'll tell you something, I've taught in schools where we had a big audience and a lot of trucks. I was very fortunate. That's kind of nice, makes my life easy as an instructor. But we were talking about this volume test on Cummins, and we happened to have 3 trucks in the shop area. And I said, all right, I had a big group. Group 1, Group 2, Group 3, go ahead and measure the volume. And would you believe no 2 trucks had the same exact volume? So what's that tell you about the fuel filters? What's that tell you about the pickup in the tank? So therefore, again, we have to do volume testing, and it's not that hard. It sits there on the side. There's the fitting right there, and you can do a volume test really easily. So again, no excuse for not doing that, because you must determine if you're getting adequate volume of fuel going to that Common Rail system. And it would be sad that you did a pump or you did injectors, whatever you might did, and you still have a drivability problem because you didn't bother to check the volume, especially with the engine under load. And yes, like I've said before in previous classes, and I get frustrated with people where I talk about the desired and actual rail pressure. I've been preaching that for years, and I hate it when a technician is asking me, what is the minimum rail pressure I should see? There is no minimum. Let me tell you why there's no minimum. Because when that engine starts up in different parts of the country, whether it be your high altitude, low altitude, high humidity, low humidity, temperature difference, is the commanded pressure the same no matter where you start it? And the answer is no. It's all programmed based on input from the sensors of where you are, such as barometric pressure. So with that said, let's get this across. There is no minimum pressure. There is the desired pressure. So as I'm doing a crank no start situation, there is a desired pressure and there's the actual pressure. Now, Ram Dodge and their Scanto calls it the set point. What is the set point? Rail pressure. What's the rail pressure itself? In this case, if it wants 7,000, it better get 7,000. I am sick and tired of teaching this at this stage of the game in 2023. If you're new, my forgiveness. My apologies, So my apologies. But if you've been in this business for a long time, really, come on. You ought to know this by now. Desired and actual rail pressure. Now, I understand. There are some cheap Scantos out there being sold that don't give you the desired or the set point rail pressure and the actual rail pressure. You got to have both. So as I'm doing a diagnosis on a drivability issue, and like I said earlier, a crank no start, there is the desire. So I'm going to crank it longer. And if you're telling me that the batteries are going low while cranking, well, you got a battery problem. You got to fix that battery problem. So therefore, definitely address that. But in this case, again, set point rail pressure and actual rail pressure. But don't bother analyzing this, especially under load or driving conditions, once again, if you haven't checked that volume. And what was that volume again? Roughly what? Somewhere like 1 liter in 30 seconds, roughly what you want to do. It's a generic number, but it works. Obviously, if we can look in the service manual, look exact spec, but it's pretty close to that. So as you can see, and the funny thing, when I talk to guys that have worked on the older 6.7s, again, from 07, 09, for example, they don't realize that the injection pump, that CP3 pump, is actually phased in. And here's directly from the service information where it's telling you there is a fuel injection pump phasing. Yes, a 6.7 CP3 pump is phased in. I know that a lot of you guys have replaced them and probably never phased them in or timed them in if you want to say that, but I like to say phasing. And you're going to see, like it says here in the service information, that there is a 750 or 754 on the shaft itself, and you're going to line up that number 5 in that 750 or 754 to the 9 o'clock position while while the crank is at top dead center. So obviously, I don't expect you to learn it right now, but just note that. Go look in your service information and go look at injection pump installation, and you're going to see that these 6.7s require the pump to be timed there. So now I'm going to go here on an edge here. I'm going to put myself out there, and maybe I'll get in trouble, but you tell me what I'm doing wrong, because if I am, you know me, I don't mind saying I'm sorry, or I didn't know, I screwed up. And that is, you're going to find on the software, here's an old Star Mobile recording, and I kept it because it's the only clear one that I recorded. It's my fault, but there's something called a cylinder performance test. And what you can see is the contribution. And I got to tell you something. I know it's in Cummins software, and I also know it's in the FCA or RAM applications. I have not been able to get anything conclusive from it. In other words, you can see the contribution, and I literally have had engines with literally a dead hole, a dead cylinder, and it showed 98, 100% that it's operating. So from my perspective, this has not been useful to tell me the power train contribution. So if I have an issue, okay, listen to me carefully. If I have an issue on these Cummins, I can kill the cylinder. So one of the few bidirectional controls that I have on a RAM, Cummins 5.9 or 6.7, is I can kill cylinders, right? Well, we actually say you got to feel it because you want to see which cylinder is contributing more power than the other. But in this case, this has not been useful because I know, like on Ford, I can use fuel trims, I can use fuel mass adaptation. While on Duramaxes, we've been able to use also balancing rates. But what about a Ram Cummins, which is a Bosch common rail injection system? What do I have to tell me? Am I underfilling, overfilling? Am I compensating what? This has been the only thing we've been able to find. Well, guess what? This has not been conclusive for me. And if you've used it, I'm open to comments, because I got to tell you, this has not been useful for all of the trucks. And guys, I would like to say I've done my due diligence. I've done it on many trucks and not been conclusive at all. But if you have seen it, let me know. I'd be more than happy to hear from you. But in this case, it has not. So what do I do to diagnose? My infrared gun, I don't have it with me right now, but in this case, I like to look at every temperature of the exhaust ports of these cylinders, see what's going on. And that has been very, very useful for me. So therefore, what I'm trying to say is the infrared gun has worked good. Now, I'm going to tell you about something that may help you, because unfortunately, there's been a lot of outfits selling trashy injectors. Yes, I say that. Like there's 3 in my area that actually all they do is clean them, I believe. I don't think they're even doing much with them. They're just cleaning them, maybe taking apart. And if you know the Bosch common rail injector, it's a finely tuned instrument. It has to have calibration. If you ever saw how Bosch goes through, and those of you know about there's shimming and so on, and everything you're supposed to do, what we're coming across is the truck's coming in with no power on acceleration. Rail pressures are great. Everything's great. But the thing is, it'll take forever. I mean, you're literally taking off from a stop and you take off, and it has no power at all. I mean, very limited power. Some will have some boost, but most of them won't have much boost until finally, after 10 seconds of accelerating, it finally comes alive. So once again, you're going to see good common rail operation, good lift pump volume. Everything's great. The engine is great. Well, my buddy Mitch, one of my good techs, some of you guys that have taken my train know about Mitch. Mitch has been my number 1 tech, my good friend. And in this case, while we were working together on one truck, that we learned from this issue was that whoever had done the engine job on this truck, because this truck came from another shop, they just did an engine in it, they put injectors in it. And again, they brought it to us because, again, no power under load. Well, Mitch looks at me and he says, you know, these idiots painted the whole engine. They just went buck wild with spray paint. Mitch looks at me and he says, you know, he goes, Tony, I can tell you what the problem is. I said, what's the problem? He goes, the problem is that we're not getting enough fuel. It's the injectors. And I'm like, wow, why do you think it's injectors? He goes, because look at the paint on that exhaust shield on the exhaust manifold. It should be burning. So I gave him the green light. Go ahead and do the injectors. All right, you're on your own, Mitch. You're the man. You know what you're doing. And sure enough, after putting the injectors and firing up the truck, guess what? Within seconds, it's burning off the paint. He goes test drive the truck, and it runs like an animal. This thing runs crazy. So therefore, What I'm trying to say is that, you actually can see a lot of bad injectors that are reman junk stuff that's being sold out there from various vendors. If you don't believe me, just do a Google search for injectors, and then you're going to see some people selling them very cheap. Kind of goes back to the phrase that you get what you pay for. So with that saying, what I'm saying is we do the MIT spray paint test. So as I travel, I'm seeing more and more trucks with this symptom, and it's usually junk injectors that are being installed. So be aware of that. So instead of using the spray paint anymore, because literally I've told people, you got spray paint around, I'll spray paint the exhaust manifold. If it don't burn the paint, that means we're not getting enough fueling. But in this case, the infrared gun has done the trick. So there, don't tell me that I don't give you any barnyard tricks there that work pretty good. So therefore, that's what we see. So therefore, your job is to look at scan data. So definitely look at scan data. So since Cummins gives you limited information about, limited controls, it does give you a lot of data. So obviously I can play this and I can show you all the data that's available, but you have to spend time in learning where the PID is, because I had a question on my earlier presentation where it says, where do you get this information? Well, a lot of it is in diagnostic trouble code charts and PID ID charts that you're going to find in the service manual. So as I've been teaching classes, I'm on location right now in Pennsylvania. And in this case, when I teach guys, I tell them, all right, you got to look up, and I'm showing them where the information that is service information. So you have to do your homework too. And now the controversial part, the CP4. As you know, Cummins on the 6.7, on the Ram trucks, they used it for, roughly two years or so. They used CP4. I still will stand with Bosch on this. And not that Bosch is giving me any money, but they're not, and that's okay. What I'm saying is, I believe the CP4 is a good pump, because the greatest problem we're having is, like I said, we see destruction of the pump. And yes, I have seen it happen on 6.7s. So after discussion and much talk, we came to the agreement that a lot of the problems with the CP4, because we know its weakness, is low lift pump pressure and air. If you're around Cummins enough, don't sit there and whine and cry at me, because I know what happened with the VP44. Anybody remember the VP44s, right? Low lift pump pressure and air, so therefore lift pump. So in this case, same thing here. I'm not saying we got bad lift pumps on there, but the thing is, we started thinking, if air and low lift pump volume is the problem to CP4, then therefore it must be occurring during service. So we're going to stick with what Ford says. Ford says that after you do the fuel filter service, they want you to let that truck idle for at least 15 minutes. And let me tell you, the trucks that we maintain, because yes, your guy right here actually does work on trucks too. When we service the trucks, we'll let them, after we're done with the filter service, we go ahead and let them idle for at least 15 minutes, and then we'll go drive it. What you're trying to do is ensure that there is no air in the system. So obviously there you can see the CP4. There's some pictures that I took at a show about it. You can see that there too as well. Now IQA codes, as you know, they actually started using IQA codes. Please note that they're programmed, but here's the scary part. Going back to that junk injectors, it kind of questions, is the IQA code matched? Now you shouldn't have any issues with it. The computer can compensate without, because you'll notice that in 2013, Cummins 6.7 quit using IQA codes. So that means it's automatically adjusting the fueling on there, and it does a very good job at it. So word to the wise. But unfortunately, with the 6.7, we continue to see turbocharger issues, but I believe that a lot of the turbochargers issues are caused by this poor actuators trying to do its job. But the problem is that it's getting massive carbon accumulation because of excessive post-injections due to frequent regenerations. So another reason why you got to know after treatment is because if you got frequent regenerations, you're running frequent post-injections, you're bombarding the poor turbo with a lot of fuel, the turbo gets a lot of carbon accumulation, and then what happens, right? So in this case, that creates a chain reaction effect. So when people want to do just the actuator, there's a 50-50 chance that it might burn up the actuator again, or it just won't calibrate. You can't get it to work. You can't get it set. So that creates, issues too as well. So again, please remember that when you look at the overall picture, we need to see what's going on with the engine that may cause frequent regeneration. So definitely want to put that. Quick trivia question here. When you look at a turbo, Hall set turbo used on a 6.7, you'll notice right in the bottom or in the center, I can't pinpoint to it, but you'll see it on the turbo on the top, there's a speed sensor. Does anybody know why they put a speed sensor on the turbo? Why a speed sensor? Well, think about this. If a rock goes across the charged air cooler, you lose all boost pressure. what happens to the speed of the turbo? What do you think a speed sensor is used for? There you go. Bet you didn't know that, some of you. So therefore, one of the things I don't understand is that you're going to see that in some cases that we see the EGR open during a regeneration, but that's another discussion. So because I got limited time here, but in this case, what I'm showing you here is, again, you're going to see that there is the EGR cooler, and some models have the EGR bypass as well, and that's what we'll notice. Another thing you might want to keep in mind when diagnosing 6.7s is the exhaust pressure sensor. We look at the exhaust pressure sensor, and at that point, we see that the exhaust pressure sensor can be an issue when the engine comes in with no turbos, and it may or may not have a code set. So if the truck comes in, it's not boosting, no boost at all, quickly, just do a quick check, disconnect the exhaust pressure sensor and see what's going on there. But when we talk about going back to aftertreatment, yes, I'm going back and forth. And in this case, you're going to notice, for example, when I fire up this truck right here, I fired it up and immediately it says regeneration in progress. I know it's not happening because the engine's too cold. But in this case, you're hoping you got a 1451 code and you can actually erase it. So obviously understand what affects and see the big picture. Are there any code set, right? Because I can't tell you how many guys on YouTube I see that are diagnosing trucks and they're running tests or trying to do this and trying to do that without even having the slightest hint of how is the air filter, for example. Can the air filter cause a premature suit-loaded DPF? Yeah. So we got to know everything. And I'm a big advocate of uncorking the exhaust. And let's fire up the truck by just disconnecting that just ever so slightly, that downpipe, and let's see what's coming down that engine. Because in the past, when we diagnosed diesels, wasn't it a great idea to see the color of smoke? White smoke, fuel. Blue smoke, oil. Black smoke, overfueling. We can see that on these engines too as well. So word to the wise there. Now, I've had experiences like this truck right here. This is the actual truck that I had where I had, you know, obviously the key is on right here in this picture, but I had no check engine light, but yet it was derated. And I ran a catalyst efficiency test and I did everything. I could not get this truck out of derate. Well, you know what the answer was? Well, I read the fine print in the service information and it said, ensure the vehicle has the latest flash. So guess what? We reflashed it and within minutes, guess what happened? You know, we ran the catalyst efficiency test and next thing you know, it got it out of derate. Though I will admit, I have had trucks in the past that actually have had, you know, numerous issues to the point that I actually had to literally program the truck up to 3 times. Yes, with the same file 3 times before it unlocked derate. So that has happened. But I guess these trucks have a whole new different character when they have high mileage. So therefore something to look out for. So in this case, like I was saying, you have to have a 1451 to run a regeneration event. And if you don't, you can't run an active regeneration as you do with the GM. So here you can have an explanation here, and you're welcome to pull it up and read about the 1451 code. Definitely can look at that. And it does explain the regeneration procedure. So I'm a big advocate, as you see me go through these slides, is I'm a big advocate about about looking and reading about service information, which you should be doing too. So therefore, you definitely need to be doing that as well. And lastly here, as I'm approaching my time, is the PM sensor. I don't have time to go into it, but please note that the particulate matter sensor is now being used. So therefore, what it is a set of electrodes. And I guess the main thing I want to talk about it real quickly on this is the PM sensor is sampling. It must take a sample, see if it conducts between 2 electrodes, and then it must regenerate itself. In other words, it heats itself up and burns the soot out, and then it takes another reading. So to say that the PM sensor is consistently monitoring the soot or particulate matter in that exhaust is erroneous to say, because it has to, again, take a reading, regenerate itself, and then take another reading. So that's what you got to understand when it's looking at a PM sensor. So many models, like even the PowerStroke 67, along with these Cummins, they do have a view of the soot, the content in it. So makes sense? So in this case, obviously there's more to it. Obviously there's more I would like to share with you, but in this case, I did put a lot of slides up here, but in this case, I wanted to show you that there's a lot to learn with Cummins 6M, but I just gave you a taste of what we see in these applications. But know your after treatment. Know your common rail. Don't ask me stupid questions like, what's the minimum rail pressure? There's no minimum. It's not Huey. Or Huey, we see 500. No. This is common rail. So therefore, we have a desired or set point rail pressure, natural rail pressure. And what was that lift pump pressure again? I mean, not lift pump pressure, volume. Almost heard pressure, right? Volume. How much volume? 1 liter in 30 seconds. So definitely. And what did I start off saying? The latching effects. How can we reset a computer on these Cummins? Again, both battery terminals, both sets of battery terminals off, connect one positive and negative together, and that'll help you reset. There's more to the story I can tell you, but I guess you're going to have to attend some of my classes, aren't you? There's my sales pitch there. So anyways. Mr. Omar, I am about at time, am I not?
Yes, sir. Well, like as always, Tony, I mean, as everybody sees here, wealth of knowledge. Now you can go on forever on the diesel engines. So we really appreciate all the information you share with us all. There are a couple questions I hear or we have here. Don't mind. Let's see. We got. This one was from Kim here. Are there any particularly tricky or difficult to diagnose issues on the Dodges that you have come across in regards to the comm rail system?
In terms of tricky, well, let's see. I don't know how you would define tricky, but in other words, misleading, I would take, or crazy stuff. When you look at the solenoid of the injector, a lot of us do a static test with resistance. But in this case, the best way is to scope it because you're testing the injector under a load. So therefore, you can see if that injector is shorting out. So I guess what I'm trying to say is it possible that a solenoid can ohm out great? In other words, the resistance checks out, but yet when you put it under load, it actually breaks down the solenoid? The answer is yes. So I would say the best way to catch those tricky injectors where you have that misfire, because if there is a shorted solenoid, it'll shut down the driver in the Cummins computer. Just remember, the Cummins computer is ECM/FICM. It's got its own built-in FICM. So therefore, it could shut down that driver. And if you know 6.7s, those injectors are in individual groups, so it will shut down that prospective injector. So you're going to think that there is a bad resistance, but it's going to ohm out great. The resistance will check out. But again, the best way to test it is under load with a scope. That would be tricky.
Well, here's another, let's see, I think this might have been in regards to one of your slides. There was a mention of 1 liter in 30 seconds.
Mm-hmm.
What RPM was the question?
No, you can only do a volume test with the key on, engine off. So in this case, this spec is based on, because you're going to have to open the system to measure that volume. So you want to see the flow from the pickup in the tank through the filters and eventually out to the pump. So you're going to disconnect at the pump and measure that volume. So this spec for volume is based on key on, engine off.
See, this might be our last one here. I might be able to answer this one too. We're running into this a lot as well. Cummins dealer won't sell us parts if it's in a RAM because of their agreement. How do I get around this if we can't go through the RAM dealer? And I guess, again, if I may, that's what, given a call to the Alliant Power technical group, or if you have access on our Alliant Power parts website, if you do come up with a Cummins part number or you have a VIN number, you can reach out with that information. We do have access to, most of these RAM systems are going to be Bosch. So, we can circumvent going through the dealer by going straight to Bosch. So if you have anything to add there, Tony.
No, I agree. Because our Cummins dealer luckily is still open to selling his parts direct as a shop. So therefore, we can give them the serial number like I mentioned in the first slide. So yeah. But I dealers are reluctant to sell to some shops. They're sending you back to the dealer. But most Cummins parts on the engines, I found that they're readily available, such as gasket sets and so on, engine-related stuff that you're going to see. So.
I think that's about it on the question side here. So again, thank you for your time, Tony. Thanks for always sharing. Be willing to share all your information with us. And I hope some of you guys out there take advantage of Tony and his training. If you need any other information there, please visit his website. I believe it's powertraintraining.com, where you'll be able to look up schedules and get in contact with Tony. So thanks again, Tony.
Thank you. Appreciate it. And thank you, Diesel Laptops and Alliant